So let's take another look at our picture. Can we get an upper bound? This is the picture we had drawn first, where we were using the left-hand method, and each box that represents a term from the sum was above the curve for the integral, and so the integral was a lower bound on the sum of the boxes. Can we get an upper bound? Well, what if instead of drawing this box this way, we draw it over this way, because we're used to switching between left and right if we have to, right? So instead of going over this way, we're going to go over this way and down, over this way and down, over this way and down. And then that makes it look like the sum is always less than the integral. Is there any difficulty there? So we're using kind of the right-hand method, right? Well, we used to have a box here at 1 that went all the way up to a of 1 and then over this way, but now we don't have that. So what we have, we're ignoring the a sub 1 value, and other than that we can say now that the integral is an upper bound on the sum, but it's the sum ignoring the a sub 1 value. So we could say the integral from 1 to infinity, or stopping anywhere in between, is bigger than the sum starting at n equals 2. That's the way we would say ignoring the a sub 1 term. And then we could think about where to add that back in. So overall what we're talking about is the integral and the sum are so tightly linked. The integral can be thought of as an upper bound in one way and a lower bound in the other way, that if one of them converges, the other one has to converge as well. And if one of them diverges, the other one has to diverge as well. So that is the integral test for a series. Maybe I'll write the word integral. And that is the integral 1 to infinity and the sum 1 to infinity both either converge or diverge. So if you can do the integral and the integral diverges, then you know the sum diverges. If you can do the integral and the integral converges, then the sum converges. And if you can do the sum somehow without doing the integral, but you can get information that way too. So remember what we had to, what were our conditions on this? Was it just for p-series? No, the diagram here, we weren't specifying exactly what formula was going on here, but it had to be ultimately decreasing and ultimately positive. As long as a sub n is ultimately decreasing and positive. And the function that goes with the sequence terms is also decreasing and positive. We don't want it kind of in between integers doing some kind of crazy dip or bump or oscillation or something. Okay, so that means if you want to test a sum for convergence, try to do the integral, and if the integral converges, then the sum converges. So let's try that in the next video.